There are places where space almost disappears entirely and time stretches. Near them, reality frays and physics works differently. Imagine a patch of space darker than the darkest void. That is an extreme vacuum, nearly absolute nothingness. It matters because our physics assumes spacetime exists everywhere. Quantum fields normally fill space with tiny fluctuations everywhere. Near nothingness, those fields vanish, leaving only rare fluctuations. Vacuum energy, a baseline curvature, sets the remaining geometry. On cosmic scales, vacuum energy drives universal expansion. A cubic meter of empty space holds a tiny energy amount. That energy influences light paths across billions of light years. So the picture is empty, yet subtly energetic and structured. Thin grid lines stretched across dark space show how distances behave. The metric is the ruler that assigns lengths and durations. When the metric shrinks, light and clocks stop agreeing. Mathematically, geodesics change and null cones tilt inward. That bends light paths and alters causal structure locally. Cosmic voids already show weak curvature across megaparsecs. Near absolute nothingness, the effect magnifies to microscopic scales. A photon traversing such a region arrives delayed and redshifted. Net result, geometry warps and signals tell a changed story. At tiny scales, space looks like boiling, frothy sea foam. Physicists call this quantum foam, where geometry fluctuates wildly. This matters because smooth spacetime arises from averaging these ripples. Virtual particles pop in and out, and geometry jitters constantly. Fluctuations operate near the Planck length, an unimaginably small scale. The Planck length is about 10 to the minus 35 meters. Averaging over a meter smooths those ripples to near zero. Bottom line, quantum discreteness may mark where nothing begins. Sometimes spacetime folds into a boundary, like a sealed room. That boundary is a horizon, where outside receives no signal. Horizons limit what observers can ever learn about interiors. Extreme warping tips light cones so everything points inward. Energy spikes or vacuum instabilities can trigger local collapse. A stellar black hole's horizon spans a few kilometers radius. Near nothingness, horizons could be microscopic and very short-lived. So boundaries form and vanish as geometry rearranges itself. Light climbing out of deep wells looks tired, stretched, and red. Photons lose energy, shifting toward longer wavelengths on exit. We rely on those shifts to read environments across space. Gravitational redshift stretches light and prolongs signal arrival. Time dilation slows clocks inside deep metric wells compared to outside. Near compact masses, seconds can stretch into years for distant observers. Spectral lines shift, pulses smear, and timing measurements drift measurably. Bottom line, light and time act as precise geometry probes. We cannot see nothingness itself, only its fingerprints on signals. Instruments measure distortions and infer missing structure indirectly. That matters because indirect signals are our only available evidence. Gravitational wave detectors sense tiny strains in spacetime fabric. Pulsar timing picks up slow drifts in clock rates across decades. LIGO measures strain changes smaller than a proton's width. Pulsar arrays detect timing shifts around 10 to the minus 15 seconds. So precise instruments translate tiny geometric wrinkles into clear signals. Picture the universe as patches, each with different vacuum energy. These patches are pockets of distinct vacuum states, side by side. If a lower energy bubble appears, it could expand violently. Bubble nucleation triggers rapid expansion at nearly light speed. The front converts surrounding space into the new vacuum state. A metastable vacuum decay could engulf galaxies in moments. So nothingness scenarios influence cosmological risk and origin narratives. Remember the opening image, a stretched, torn canvas of reality. That simple picture captures what near-absolute nothingness might look like. Detecting those traces would open a brand new frontier in physics. If you enjoyed this calm deep dive, please subscribe for more. Net result, nothingness looks empty, yet tells a complex story.